Hello everyone, welcome to today's 2.3 Day 2 notes, pre-teach Day 2 notes on using factoring to sketch the graph. Our first example is y equals x squared plus 2x minus 8. And we're asked to factor it. So leave this out of your mind for a moment, the fact that it says y equals. Let's just focus on this quadratic. I see that a is 1, so we need two numbers that multiply to negative 8, add to 2. So in my brain, I'm thinking 4 times 2 is 8. And if the 2 is negative, that takes care of this being negative, right? Positive 4 times negative 2 is the negative 8 that I need. And then when I add these together, I get my middle term, factors of C that add to B. So this factors to be x plus 4 times x minus 2. And now we're going to address the y equals part. We're going to set this equal to 0 to see where does this quadratic equal 0, literally. To figure this out, we need to identify that we have a piece times a piece. So there's some value of x that makes this piece equal 0, and there's some value of x that makes this piece 0. So we can take each piece, set it equal to 0, and solve. Here, I subtract 4 from both sides, so I get x equals negative 4. And here I add 2 to both sides, and I get x equals 2. So let's think really closely about what we just did. We let y be 0, and I'm hoping that concept of letting y be 0 is a little bit of a blast from the past from Algebra 1. When you let y equal 0, that's a y, let me fix that. When you let y equal 0, finding x intercepts. You did that a lot in Algebra 1, and no matter the function family, that process of letting y be 0, no matter the function you're looking at, that's finding the x-intercepts. So what you really just found was the ordered pair negative 4 comma 0 and 2 comma 0. Here on the right is the graph of y equals x squared plus 2x minus 8. And the question says, do you see any relationships between the quadratic trinomial and the graph? Look at the factored form x plus 4, x minus 2 that led to our x-intercepts and check it out. Here's the graph crossing at negative 4, and here's the graph crossing at 2. And that is an awesome little preview of today's learning in one place. This is what we're going to focus on learning how to do today, where we take our ability to factor. This is our knowledge coming into today, how to factor, and then make a connection to setting those factors equal to 0 and solving to find your x-intercepts, and then how does that connect to the graph? So our key takeaway from this question, the relationship between the quadratic trinomial and the graph, the factors can help determine or find the x-intercepts. When we're dealing with graphs, we have a new vocab word to discuss, and it's the concept of zeros. Zeros, by definition, are the x-intercepts of a function. By factoring, you can determine these two values. So big takeaway, whenever you see the word zeros, we're talking x-intercepts. Why it's called zeros, that I'm not sure. We found a little side research project where that came from. If anybody's really interested, Google, I'm sure, could help out with that. But zeros and x-intercepts, they mean the same thing. So whenever you see the word zeros in any set of direction, find the zeros, you're being asked to find the x-intercepts. Let's talk about our steps for sketching a graph. Let's highlight this and work on the process together, and then we're going to put it to work. So let's get the common language here first. Step number 1, set the equation equal to 0. That's that idea of let y equal 0, right? Let's go back and look at that from up here. Setting the equation equal to 0 was letting y equal 0. So you set the equation equal to 0. Next, we are going to factor the quadratic. Then we will set each factor equal to 0 and solve for x. These are your x-intercepts. So once you have your x-intercepts, we're going to plot the x-intercepts on the x-axis. And last but not least, sketch the parabola using the sign of A. Sketch the parabola using the sign of A. So these are going to be our steps. We have a quick reminder about the sign of A. So let's actually kind of like exaggerate this for our brains. Positive A value. So if A is positive, it opens up. Right away we know that. If it's a positive A, it opens up. If it's a negative A, I don't need to know anything else other than the fact that A is negative to know that this graph is going to open down. So that's what it means when it says sketch using the sign of A. Once you have your x-intercepts, you're either going to sketch this opening up or you plot your x-intercepts and you sketch it opening down. Let's practice. The directions say factor the given trinomials and find the zeros. Use the zeros to sketch the quadratic. So again, as soon as you see the word zeros, we are thinking x-intercepts. Use the x-intercepts to sketch the quadratic. Step number 1, set it equal to 0. So 0 equals 2x squared minus 6x minus 20. Before we can go any farther, we're always going to want to remember to look for the GCF. So after setting it equal to 0, before factoring, always check for a GCF. Do we have one right here? 2x squared minus 6x minus 20. Yes, we do. We can factor out a 2. So if I put a line down my equal signs to keep this nice and neat, we now have 0 equals 2 on the outside. And then what's left inside? 2 divided by 2, that cancels out. So we have x squared minus 3x minus 10? If yes, factor out GCF. Then factor what's left inside the parentheses. So inside our parentheses, we now have x squared minus 3x minus 10. So that's what we're going to factor. This 2 is just going to chill on the outside. So I need two numbers that multiply to be negative 10, add to negative 3. So I'm thinking 5 and 2, where the 5 is negative. So this factors to now be 0 equals 2 times x minus 5 times x plus 2. I've successfully factored it. Our next step is to say, okay, well, what value of x makes this 0? Or what value of x makes this 0? Side note, this 2 doesn't play any role in our next step, because remember, that just determines, is this a vertical stretch or a vertical compression? The a value, when it's just a constant like this, just a number, has no effect on the x-intercepts at all. So we get to just ignore it. It needs to stay here. Like, this can't just disappear. But when we set our factors equal to 0, that's not going to be part of what we do. We're just going to take x minus 5, set that equal to 0, x plus 2, set that equal to 0. Using our mental math skills, this gets us 5, and subtracting 2 from both sides, negative 2. Those are our x-intercepts. So I go 1, 2, 3, 4, 5, 1, negative 2. I've plotted my x-intercepts, and our last step is using the sign of A to know if this opens up or down. Here's my A value, right? So it's a positive A. So I'm going to sketch this opening up. Notice I have not made any type of table. We're not concerned with the vertex right now. We're purely practicing the skill of finding the x-intercepts by means of factoring, and then using A to create an accurate rough sketch. So this x-intercept was at negative 2, 0. This is at 5, 0. Again, for emphasis, A is a positive 2, so I know it opens up. Sketched it opening up, and we are done with our first example. Let's practice. This process repeats. Example number 2. First step, set it equal to 0. So 0 equals negative x squared plus 2x plus 3. We have a GCF here in disguise. That negative, so remember, negative x squared means negative 1x squared, which means we have a GCF here of negative 1. So before we do anything else, we have to factor out that negative 1. The next thing about factoring out a negative 1 is it doesn't change anything other than the signs. So negative 1 is going to stay out front. And then this becomes x squared minus 2x minus 3. Remember, the GCF is just going to hang out there out front. And we're now focusing on factoring what's inside the parentheses. A is 1, right? There's a 1 right here. So I need factors of negative 3 that add to a negative 2. Well, my only options are 1 and 3, right? This is negative, so we have to decide which of these needs to be negative so that I get a negative 2. And I'm hoping 3 being negative is popping into our minds here. So to factor this, 0 equals negative 1 is still outside. X plus 1 times x minus 3. There's my factored form. What do we do next? We need to find what value of x makes this 0, right? Because 0 times anything is 0. There's a different value of x that makes this 0. 0 times anything is 0. So we're going to take each of those factors one at a time and set them equal to 0. Use our mental math skills. This gets us -1. This gets us 3. Those are our x-intercepts. 1, 2, 3. -1 is right there. To know how to graph, remember we're going to look at the sign of a. So for us, a is negative, right? A was a -1. So -a means this graph is going to open down. This is -1, 0. This is 3, 0, and we are done. Remember, our focus today is just rough sketching by means of the intercepts. Could we technically go find the vertex? Yes. Could we technically go find the y-intercept? Yes. Could we make a table? Yes. But that's not our focus today. The focus is realizing the power of factoring and its connection to finding our x-intercepts. So once you plot your intercepts and use the sign of a to determine, does it open down or does it open up? That's as far as we're going with today's learning. Let's make example 3 and 4 a U-try. We're going to do them one at a time. So press pause. I want you to try example 3 first. When you press play, we will check answers on all of example 3. So you can work with a partner in class. Your partner can be these notes that you just took. But press pause right now, please, and give example 3 a try. When you press play, we will check answers on number 3. Please press pause now. Welcome back. How did we do? I arrived at a GCF of 3. Factor that out. This is what I had inside. Factored, set the factors equal to 0. I have x-intercepts at 9 and 2. Plotted those points. Positive a opens up. If you need to press pause to check your work step by step, please don't hesitate to do that. And if you are ready to move forward with me for example 4, let's do it. So when you're ready, again, press pause if you need to, check answers. If there's a piece that's not making sense, please don't hesitate, let me know. Send me a quick email. If we are ready, fantastic. Let's move forward to example 4. Please press pause now. When you're ready, we're going to move forward to number 4 here. And I will put a hint before I ask you to press pause. This does have a negative GCF. So I'm just going to write that little hint over here off to the side. Negative GCF. Please press pause. And remember, let's say we're a little shaky on the process for number 3. For number 4, which is also a U-try, you can always now come back here and reread your steps. So this is the mental conversation for how to approach each of these questions, right? So at this time, please press pause now and give number 4 a try. When you press play, we will check answers. Reminder, the spacebar is a shortcut for pressing pause. Please press pause now. Welcome back. How did we do? So for me, I identified a GCF of -2. I factored that out, being very careful to also account for my signs, right? Negative divided by negative is a positive. Here, positive divided by negative is a negative. This is what I had remaining inside my parentheses. So I was looking for factors of -24 that add to 2. I came up with 6 and -4. That led to the factored form of -2, GCF on the outside, x plus 6 times x minus 4. Remember, for emphasis, this has no effect. I'm going to put it in purple. This has no effect on your x-intercepts. This a value determines that it's going to be opening down, and that it is a vertical stretch. No effect on the intercepts. It does need to chill there. You can't just make it disappear. So it just needs to stay right where it is. We set our factors equal to 0, and that gets us x-intercepts of -6 and 4. So I plotted my x-intercepts, and this is opening down because a is negative. How did we do? So take a moment, check your steps against my steps. If there's any questions again, please let me know. I'm hoping this went well. These steps don't change. So for emphasis, use these steps as a reference and as a guide, and practice makes perfect. So please log into your Delta Math, and we have a mixed practice that has you continuing to practice your factoring when a equals 1 skills. And then there is a topic, maybe 2 topics, that has you practicing this concept of getting to your x-intercepts from factored form. On the next page, we have the homework for today on page 52. That wraps up our learning for the day. So I hope this lesson has gone well for all of us. Any questions, please don't hesitate to send me a quick email. And I hope you have a fantastic rest of your day. This homework, for reference, is on page 52. Ooh, that's a 5. Let's try that again. Page 52.